Section 1.4a is about the identity and equality properties. The first property we'll look at is called the additive identity, and it says that the sum of any number and 0 is equal to that number. Well, what does that mean? That means if you take some number like 4 and you add it to 0, you're going to get 4. If you have negative 13 and you add a 0, you'll get negative 13. In other words, what you start with is exactly what you end with when you add nothing. That's called the additive identity. There's also a multiplicative identity, and it says the product of any number and 1 is equal to that number. Well, again, if we start with 4 and we want to end with 4, what can we multiply it by to get the same thing? And the answer is 1. Likewise, negative 13 times what gives me negative 13? The answer is 1. Notice both identity properties start with a number and end with the same number, either when adding something, that's the additive identity, or when multiplying, that's the multiplicative identity. The next two vocabulary words we'll do are multiplicative inverses and reciprocals. The reason I put them together is because they mean the same thing. It's what we call numbers whose product is 1. If I take a 9 and I multiply that by 1/9, you're going to get a 9 over a 9, which is a 1. So I can multiply the number 9 and the number 1/9 and get a 1. Those are multiplicative inverses or reciprocals. And how about negative 1/2? What can you multiply that by to get a 1? The answer is negative 2. And the last vocabulary word is a multiplicative property of 0. That means the product of any number and 0 is 0. 5 times 0 equals 0. Negative 6 times 0 equals 0. No matter what you multiply 0 by, you end up with a 0. That's the multiplicative property of 0. Here we're going to do some examples where we name a property that's used in each step and we find the value of n in each equation. I find it easier to find the value of n first, and then that helps me determine what property we're going to use. So the question we have to ask ourselves is 42 times what is 42? And the answer to that is 1. When you multiply 42 times 1, you get a 42. Now, what property says that I can multiply 42 times the number 1 and get the same thing? I start with a 42 and I end with a 42. Sounds like an identity to me. And in this case, we're multiplying. So we'll say the multiplicative identity, or the multiplicative ID, is the property. Second one, what plus 0 is 15? Well, the answer here is 15, n has to be 15. So to find the property, we think 15 plus 0 equals itself. Well, if it starts something and ends out the same, it's got to be an ID, or an identity property. So what can we add to it? We add nothing, and that's called the additive identity property. Last one says that something times 9 is 1. Well, if you're going to multiply by 9 and get a 1, you better multiply by the reciprocal, also known as the multiplicative inverse. So n is 1/9, and the property is the multiplicative inverse property. As you can see, I like to abbreviate. Here's some more. 13 times what is 0? The answer is 0. And when you multiply anything by 0, you get a 0. That's the multiplicative property of 0. Says you can do that. Here, 17 plus nothing equals what? The answer is 17. And if you start with 17 and end with 17, sounds like an ID, but we're adding nothing. So that's called the additive identity. And the last one, 1/6 times what will give you a 1? Well, the answer is 6 over 1. So n is going to be a 6, or 6 over 1. And that's using the reciprocal, also known as the multiplicative inverse property. For these next 4 properties, called the properties of equality, I'm going to use this table here. I'm going to refer to it, and then we're going to do a quick example down on the bottom here to practice. The first property is called the reflexive property, and all it says is that something equals itself. It's really just that easy. If you see one thing on the left of the equal sign and it equals itself, it's called the reflexive property. The way that I remember that is I think of the word reflection, and it's like looking in a mirror, so I remember reflexive property. Second one is called the symmetric property. It's not quite as easy as the reflexive property, but it's very close. It says if you start with something like a 9 in this case, it has to equal 6 plus 3, because 6 plus 3 is also equal to 9. And it also says that you can flip those around and make it 6 plus 3 equals 9. So in other words, it's saying that the order in which you write an equation doesn't matter. Both sides are still symmetric. The third property is very rare to be used. What it says is if you have one quantity and it equals a second quantity, the second one then equals a third quantity, that you can say the first and the third must be equal. Here's an example. 5 plus 7 equals 8 plus 4, and 8 plus 4 equals 12. Therefore, we have to say that 5 plus 7 must also equal 12. It's the only one that uses three quantities, and it's the only one that involves the word and. So if you see the word and involving three properties, you're probably going to see the transitive property. The last one is the one that's used probably more than anything else. If you don't know what property it fits into, it's probably going to be substitution. And it just says that you can substitute any value that's equal in for another. So in other words here, 3n, instead of n, I can use a 15 because n equals 15. So I can substitute 15 in for n. That's all it says. So let's go down here and do this matching exercise. Number 1, if 2 times 6 equals 3 times 4, and 3 times 4 equals 12, then 2 times 6 equals 12. Well, notice it has three exercises or three expressions. It's got the word and there that we talked about here for the transitive property. So number 1 goes with C. We'll look at number 2. 19 minus 2 equals 19 minus 2. It's the same exact expression on both sides. It's like looking in a mirror. That's the reflexive property. Next one, 6 minus 2 times 4 equals 4 times 4. Well, all we did is we replaced 6 minus 2 with a 4. In other words, we substituted a 4 in place of the 6 minus 2. That should go to D. And the last one, 5 plus 3 equals 8. All we did was flip the sides and make it 8 equals 5 plus 3. It's not quite like looking in a mirror, but the two sides are still equal, and that is the symmetric property.